There are several gas laws and many equations related to these laws. But really, only a couple of those equations are considered as key equations. So if you can remember these key equations, then you don't need to remember all of those equations related with the gas laws. So one of the key equations is the one that describes the combined gas law. After reading this question, you notice that the pressure before the change and after the change, or in other words, P1 and P2, they are the same. P1 equals P2. So therefore, I can just cross that out. And now you see this combined gas law becomes the Charles law. Thus, we can also cross out those two quantities. So I just said that the combined gas law in this case becomes the Charles law. So, and this is the Charles law equation. Now let's identify the remaining quantities. So if we assume this is before the change, so therefore 12.9 liters, that should be V1, and this is T1. And then after the change, this is V2, and now T2 is the one what is asked, all right? So therefore, we need to find out what T2 is. Some students would have a little bit trouble to find out the unknown, or the ones need to be calculated. But if that quantity is as a denominator, so some students had problem with that. If that's the case, you can basically just inverse V1 T1 to T1 V1, and then the same thing, T2 V2. So this equation still stands, even though this is not the same as the Charles law, but the relationship is still correct, and now it's easier to find out what the T2 is, all right? So what is T2? You just move the V2 to the other side, copy T1 over V1, and V2 now as a denominator on this side, then once you move to the other side, that should be a numerator, all right? So therefore, we can pull that right there, okay? Now we are ready to calculate T2 because we already know T1, V1, and V2. Okay, T2 equals T1. What is T1? 62.2 degrees Celsius. But please remember, the temperature in all of those gas law equations, the unit has to be Kelvin. So therefore, we have to convert the temperature from degrees Celsius to Kelvin. Basically, in this question, 62.2 plus 273.15. So that's T1. Then T1 times V2. V2 is 11.7 liters. And then divided by V1. So V1 here is a 12.9 liter. This gives us 304 Kelvin. But what is asked in this question is, what is the temperature in degrees Celsius? So then we have to convert the Kelvin to Celsius. So Kelvin subtracted by 273.15. Yeah, we got 31 degrees Celsius. That should be the temperature asked in this question.